here we're going to revisit the triangle group called Compa. So let's open Compa. And if you open the paid losses triangle, you might remember that it's quite volatile on a percentage scale, and that's the way you should measure volatility. But yet, in a previous video, when you remove the last 9 calendar periods, you predicted the distributions of the 161 observations you left out, and you still get the same distribution of reserves, at least statistically, as if you were doing your modeling at the end of the first quarter of 1995. Now, if we just revisit model optimal all opt all, you'll see that run it. You'll see that the trend along the calendar years is 0, and the wizard did that. But if you re-estimate the trend, if you actually find out what is the average iota, so you go to the residual graph, the third quarter to the fourth quarter of 89, add a parameter, and you'll see that it's insignificant when you go back and look at the model display. But then there's a lot of process variability. In fact, that causes the volatility, that explains the volatility of those numbers. And I guess in the presence of any other information, you should actually use this uncertain trend. But the true trend comes from a normal distribution with mean 1% and standard deviation, say 1.4. Now let's close this triangle group. So you go to X with the downward arrow, close all triangle groups. Let's not save this. And now go to type of TG, which is composite. And composite. Yeah, and there's one called Compa plus MAA951. Compa is all the BI data, MAA951 is the whole industry. Open that. And if you go to related models, let's run model optall for Compa and model good one for MAA951. Okay, so we're going to run both, either by clicking on MPTF or with the right button of our mouse, open, tile vertically, minimize regression tables. So if you look at the industry, MAA951, you'll notice that it's got huge calendar year trends. And these are this is quarterly calendar period. So these trends by year, they're absolutely huge. But if you look at Compa, which is a company that writes somewhere between around 2 to 3% of the industry data, along the calendar years, it's got a pretty stable trend. You know, the trend was not significant. We set it to 0. Okay. What we'd like to do now is credibility adjust this trend. Remember when we estimated using just the Compa data, it was something like 1% plus minus something. And also, for the development periods, if you look at development periods for Compa, it was also insignificant, this trend here. And, you know, you kind of want to know, well, hold on, if we use industry data, if you look at the industry model MAA951, click on that tab, the trend from going from 13 is actually negative. If you look at Compa, it doesn't look like from 13 it's going to be negative. So anyway, what we're going to do in order, is there any process correlation? Just click on CO. In order to, yeah, there is some process correlation. So in order to credibility adjust the parameters of Compa using the industry data, what you really need to do is reinstate all the parameters in both models. And the way to do that is you click with the right button and reinstate all parameters. So now you look, if you look along the accident years, you've got all these L's. If you look along any other direction, if inflation was set to 0, the parameter's been reinstated. So this parameter for the company which is now slightly negative, because if you didn't use the industry data and you set the process correlation to be 0, it'd be slightly positive. Didn't we also say that there was a trend between 13 and 14 in the industry? Can you see? Let's also insert it for the company, 13 to 14. So we're just inserting another trend parameter. And now what we're going to do is optimize. When you do the optimization, let's do that. But you need to estimate first. So we're going to estimate. And now, if you click on 00, let's click on 00. Okay, we find in fact that this 0 trend is still there. In other words, there's no evidence using the industry data, even though for the industry standing at development year 13, it was pretty strong negative, that there was a negative trend again. In fact, if you look at the residual, 0 kind of makes sense. Along the calendar years, we have credibility adjusted that trend parameter, and it's now 2.95 plus minus 0.64. So it's the same as the industry parameter. If you click there, for the periods up to the second quarter of 91. So let's check that. So in order to get this table cross dataset constraints, you just click on the red, and you can see that for company A versus M00951, the third quarter to the first quarter 95 is the same as that. But you'll also see that in the model. If you go to M00951, we've set this trend in the early years, early periods for the industry to be the same as that for the company. So statistically, it doesn't make sense to adjust the development period trend, but the color. Let's save this model as a credibility for Comp A. Okay, let's save it. Let's do a forecast, but only for. So we remove the data set MAA951 from the selected data sets. If you click on OK, the answers we get now is 143. Okay? Now, let's run in a new window. So we go to the downward arrow here next to model load, or load model. The related models again, which were opt all and good one for the industry. So I'll wait for you. Highlight those two with your left button of your mouse and your control key. Load these. Set the correlation to 0. Set all correlations to 0. And now do a forecast just for Comp A. So that's the kind of answer you would have got in PTF. Forecast summary. And let's do the right button on the forecast summary tab. And let's dial vertically, minimize other types. So 143 versus around 130. Now, and of course, the 130 has a coefficient of variation of 11%. The 143 doesn't have a much higher coefficient of variation, high CV, because we also use the industry data to estimate some of the parameters for Comp A. I think some of the development period parameters were also set to be equal to the industry. So if I click on this forecast summary and click on model display, you'll see that, these two development period parameters were also to be set to be the same as the industry. Let's close that. Let's load the model again in a new window. Load model in new window. Well, the other thing you can do is, where you have an answer of 130.8, make that active and save that as good one, opt all, say independent. In other words, the correlations have been set to 0. So now load in a new window, load model in new window, good one, opt all independent. Now go to the residual display and add a parameter between the third quarter of 89 to 84. Okay? Estimate that. And if you now click on the model display, the estimate is around 1.08 plus minus 1.37. Now some of you will say, hold on, that's not what I got in PTF. Oh, that's an interesting question. In MPTF, we've made a slight change, and that is that when we calculate the sigma squared, we use the maximum likelihood estimator also for calculating the standard error of a parameter. In PTF, we use the unbiased estimator. And the reason for that is that if you've got process correlation and you're estimating parameters using both data sets, then it's very hard, well, it's impossible to determine how many parameters are actually used because of cost parameter constraints, how many parameters are actually used in the model for that individual data set. So to make it sort of more consistent, I guess, or statistically sound, we use the maximum likelihood estimator. But you can always go to model, it's an option, and switch to UB estimation. But there's not really much difference. Now let's forecast. Now we're using this particular trend, forecast. We only want to do it for comp A. We move. Okay. Forecast summary. Tile vertically. Call fast summary with the right button. Choose all. Tile vertically. Now minimize other types. So there's over 3 answers. The 137 you would use if you only had the comp A data. And the reason for that is you got a lot of process variability. It doesn't make sense to use a trend of 0 because there could be a trend in the data. You just don't have a good estimate of it or credible estimate of it because of a lot of process variability. The 130 is when you assume the trend is 0, which is a little bit too optimistic. Whereas 143 is using the collateral data, the industry data, to just credibility adjust that trend and 2 development period trends in the early development periods, but not the last development period trend. Hopes this has been useful to you.